dear students, how are you all? I hope all of you are learning and doing fine because learning, keep practicing, staying hydrated, and keep smiling is really very happy, right? So, students, as we discussed that it's really important for you all at this point of time to practice the previous year questions, right? Why is it important, students? Because by practicing previous year questions, student, first, this will give you an idea that how CBSE is framing questions. Second, you will have an idea of what are the topics which are being asked repetitively, right? And third thing, see students, you should always believe in one quote. And what is it? That practice makes the man perfect. So, in order to be perfect, you need to practice, right, students? So, as more number of questions you will practice, you know what will happen? Your brain will automatically know that okay, this is the topic. These are the main highlighted points of these topics. I have to process this question in this way, right? So, it's really important. So, now, students, what are we going to do? As discussed, students, we are going to practice the multiple choice questions of the year 2025, the latest paper. Why? Because first practicing the latest questions will help you analyze, will help you grasp the concept that CBSE is now shifting towards application based questions, right? Now, in this, when we are practicing these questions, you will observe that there are no direct questions. Okay, I'm not saying totally no, but there are few direct questions, students. Most of the questions are case based, application based, so you need to keep that in mind. So what are we waiting for? So let's go, learners. Yes, come on, learners. So we are on the first question. What is the first question saying, dear learners? That electrolysis of water is a decomposition reaction. Do we all agree that electrolysis of water is a decomposition reaction? Yes? Yes, it's a decomposition reaction. And why is it a decomposition reaction, students? Because water is breaking down into simpler substances, hydrogen and oxygen. So I know that decomposition of water is electrolysis of water is a decomposition reaction, right? So what I'm going to write, I'm going to write the reaction. Let's do that. What it is? Twice of H2O. See students, I'm going to write the balance reaction. And why is it important, students, to write balance reactions? Because since the first topic which you have studied in this chapter, chemical reactions and equation, is to balance your equation. You have to always go with balanced equations. Please keep that in mind. Okay, so twice of H2O will give 2 hydrogen and one oxygen gas molecule. Now students, please pay attention. What is the question asking from you? We have written the decomposition reaction. The mass ratio of hydrogen to oxygen is, that is, it is asking MH is to MO, right? So now, as I know that H2, one molecule of H2, what is the mass of one molecule of H2? 2, right? So how many molecules do I have here? There are two molecules. So 2 times 2 is 4. So what is the mass of hydrogen here? 4. So now mass of one atom of oxygen is 16. For oxygen gas it is going to be Yes, students. Obviously, for oxygen gas, it is going to be 16 times 2. So, this will become 32, right? So, what I have to do? 4 is to 32. What is 4 is to 32, students? It is 1 is to 8. Correct? So, what is the correct option? D1 is the correct option. Now, we can say this is much type of a direct question. What you need to keep in mind, students, here is that you have to process through a balanced chemical equation. This is the main important point, students. Please process through a balanced chemical equation whenever the question is asking you about the ratios of mass of maybe the products. For this time, it's asking for the products. So please always take the balanced reaction, right? So now let's move on to the next question. Now, again, what is it saying? The correct balanced chemical equation showing an exothermic reaction in which natural gas burns in air. Again, this question is from your chapter Chemical Reactions and Equations, right, students? So, as we know that methane is the natural gas, and when methane burns in the presence of air, what type of reaction is this? Who is going to tell me? Yes, students. This is a type of combustion reaction, right? So when methane burns in the presence of air, what is going to be the reaction? Let's write the reaction. Okay, give me a moment, students. Yes. So let's write the reaction. What is going to be my reaction? So my reaction is going to be methane when burns in the presence of oxygen. So I have CH4 and O2, which gives me, you have to always remember, when methane burns in the presence of oxygen, it gives you carbon dioxide and water, and also it also releases energy, right? It also releases energy. This is the most important point, because this is an exothermic reaction. So students, you cannot miss on that point. Now, this is not a balanced reaction, right? So first, what I have to do, I have to balance this reaction. How am I going to balance this reaction, students? See, here I have two atoms of oxygen, but here I have three atoms of oxygen, so it is not balanced, right? So what I have to do, so what can I do to balance all these things? Again, I have four atoms of hydrogen here, and here I have two atoms. So let's make four atoms of hydrogen first. Let's start with hydrogen. So what I'm going to do, I'm going to put a 2 here. So when I put a 2 here, students, now the hydrogen is balanced, right? In the reactant side also, I have four atoms of hydrogen. In the product side also, I have four atoms of hydrogen. Now, what is the scenario for oxygen? In the product side, I have four atoms of oxygen, but in the reactant side, I have only two atoms of oxygen. So what I'm going to do, I'm going to simply write a 2 here, right? So now, check all these things, all the things. That is my reaction balance. Yes, methane when combines with oxygen gives you CO2, that is carbon dioxide, plus water and energy, and my reaction is also balanced. So which is the option which is following this? Let's see. So CH4 plus twice of O2 gives you twice, no, we are not getting two molecules of CO2. So this one is not the reaction. Now, this one is not the reaction because here it is not showing energy being liberated, because since it is an exothermic reaction, so energy is liberated. So what is the correct option, student? D is the correct option. CH4 plus twice of O2 gives you CO2 plus twice of H2O plus energy, right? Okay, students, let's go ahead. Now, student, the third reaction. Again, it is from the chapter Chemical Reactions and Equations, right? So, let's study. Study the following cases. Copper sulfate when combining with magnesium, ferrous sulfate with combining with lead. Then we have calcium sulfate when combining with aluminium, and zinc sulfate when combining with calcium, right? So, what is needed to be done here? Give me a moment, students. Yes, students. Again, I'm going to write the combustion reaction here so that it is clearly visible. So what is happening, students? The natural gas. What is the natural gas? Methane is our natural gas. So when methane, yes, students, give me a moment. Let's first discuss the previous question, right? So what is the previous question saying? That we have to give the correct balance equation when methane is burning, right? Methane is burning in air. Methane is burning in air, student. That means it is burning in the presence of oxygen, right? So what I have to write, I have to give a balanced chemical equation. What is going to be my balanced chemical equation, students? CH4 plus twice of O2 is going to give me CO2 plus twice of H2O plus energy. Energy is also released, students. It is an exothermic reaction. Now I have also balanced these. I have written the balance form of the equation. How I first started with the hydrogen. Uh, so first I balanced the hydrogen. In the reactant side, I have 4 hydrogen. And now let's check in the product side. 2 times 2 is 4. So in the product also I have 4 hydrogen atoms. Then in the reactant side, let's check in the product side. So in the product side, 2 atoms of oxygen from water molecule and 2 atoms of oxygen from carbon dioxide. So 4 atoms of oxygen. Similarly, on the reactant side also, I have 4 atoms of oxygen. And this option, which is correct, according to the reaction which I have written, is the option D. So the correct option for this question is going to be option D. See, students, this was a direct question. You can consider this as a direct question because we all know how natural gas, that is our methane, burns in air, and what we have to do, we have to just balance this reaction, right? Now let's come on to question third. What is the question third saying, students? The question third is saying when copper sulfate combines with magnesium, then when ferrous sulfate combines with lead, when then what is it saying, when calcium sulfate combines with aluminium, and when zinc sulfate combines with calcium, the cases in which new products will be formed. Okay, students, so now this is an example of your what kind of reaction, student? This is an example of your displacement reactions, right? Now again, first thing you need to keep in mind, you need to keep two things in mind, student. What are the two things that you have to keep in mind, students? That first, this is the example of displacement reaction where one metal displaces another metal from its salt solution, right? Second thing which you need to keep in mind is reactivity series. Remember, student, we have studied reactivity series in the chapter metals and non-metals, right? So the metal which is at higher position in the reactivity series is going to displace the metal which is at the lower position in the reactivity series. So I hope, my dear students, that you all know what is reactivity series. In case if you don't know, then also don't need to worry. I am here. So let's do it together. Let's first write the reactivity series just to give you a quick recap. So I know first in the reactivity series is potassium, then sodium, then calcium, then magnesium, right? Then aluminium, then, yes, students, then zinc, then iron, then, what is it? It's lead, right? Okay, give me a moment, students. Then it's lead, and then what is it, students? Yes, students. Iron, then lead, right? Lead, and then we have copper, then we have silver, and then we have gold. So keeping in mind our reactivity series, Okay, students, we were on question third, right? And I wrote reactivity series, right? So in reactivity series also, I told you what is reactivity series, in which we have arranged the metals in order of their decreasing order of their reactivity, right? So the first which comes is sodium. I have what I have. First is sodium. Oh, sorry. First is potassium, students. Potassium, then sodium, then calcium, then magnesium, then aluminium, then zinc, then iron, then lead, then copper, then silver, right? So according to this, now what we have to decide, that which metal is going to displace which metal. Obviously, since magnesium comes high up in the reactivity series, so definitely it is going to replace copper from its salt solution and is going to form MgSO4, right? Now lead comes before. Now you tell me, students, is lead going to displace iron from its salt solution? Yes or no? No. Then comes aluminium. Is aluminium going to displace calcium from its salt solution? No. Then comes calcium. Is calcium going to displace zinc from its salt solution? Definitely yes. So the option which follows this is first and fourth. So option C, which says first and fourth, is the correct option. Right, students? I hope you understand this concept. In this concept, we need to take two things in mind. We need to keep two things in mind. First is displacement reaction. Second, the reactivity series. Let's move on to the next question, students. Consider the following reaction: dilute HCl and NaOH, magnesium oxide with dilute HCl, carbon dioxide with sodium hydroxide. See, students, what is happening? It's saying that in each case, what is found. So I know that in first case, an acid is combining with base. So what happens, student, when an acid combines with base? Neutralization reaction occurs, right? When acid combines with base, salt and water is formed. So in each case, salt and water is formed in the first case. Now let's consider what is happening in the second case. In the second case also, magnesium oxide, which is a basic oxide, is combining with HCl. So salt and water is being formed. Again, carbon dioxide is combining with sodium hydroxide. Carbon dioxide is acidic, sodium hydroxide is basic. So again, it's a kind of neutralization reaction. Neutral salts are formed? No, students. Every time neutral salts are not formed. Hydrogen gas is released. Hydrogen gas is not formed. Acidic salts are formed. In every case, acidic salts are not formed. So what is the thing which is happening in each case is that salt and water are formed. So the correct option for this question is going to be my option A, right? So for this one, what I have to keep in mind, I have to keep in mind the concept of neutralization reaction, as well as I have to keep in mind what are acidic salts, what are basic salts. Okay. Now question number 5, students. This is from your chapter metals and non-metals. Let's study the question first. Reaction between two elements A and B forms a compound C. A loses electron, B gains electron. Now student, here first, what is the thing you need to keep in mind? A is losing the electron, B is gaining the electron. What kind of bond is formed? Ionic bond is formed. What kind of compound is compound C? It is an ionic compound. We all know that ionic compound have high melting point. We all know that ionic compound are highly soluble in water, right? Then we all know that it conducts electricity in its molten state. And what we have to keep in mind, that ionic compounds have strong electrostatic forces of attraction, right? It does not have weak electrostatic forces of attraction. It has strong electrostatic forces of attraction. So obviously this is the property that is not shown by my ionic compound C. You have to realize that when there is a complete transfer of electron, then which kind of bond is formed? An ionic bond is formed. So an ionic bond is formed because the C is our ionic compound. So you have to keep in mind the properties of ionic compound, students. Now, again, consider the following reactions. I don't know what is P, what is Q, what is R, and what is S, right? When aluminum is combining with water to form aluminum oxide. So what I have to do, students? Again, I have to balance this chemical equation, right? So let us balance this chemical equation, students. So now, up till now, what you have observed that the questions regarding balancing the equations are coming. They are showing up, right? So now let's first balance this equation. Okay. So let me write Al, that is aluminium, combining with water gives me Al2O3 and H2 gas. Now, let's first take aluminium. In the product, students, I have two atoms of aluminium. In the reactant, I have only one. So let's make it two. Aluminium is done. Now, in the reactant side, I have two atoms of hydrogen. In the product also, I have two atoms of hydrogen. But in the product, I have three atoms of oxygen, right? But in the reactant side, I only have one atom. So what I need to do? I need to make this three, but I cannot make this as three, right? What will I do then? I can multiply, uh, since the three is here. So what can I do? I can multiply this aluminium oxide by 2. Okay, students. So now when I am multiplying, no, but multiplying it by 2 would make this 6. So this can also not be done. Then students, what is the correct option? What should I choose? Okay. So what is the correct option? Let's move on to that thing. Let's first erase that. I am not going to write 2 here. Now what am I going to do? Let's check. So I balance the aluminium, right? So now there is no problem with aluminium. For which I am facing the problem. I am facing the problem with oxygen because I have 3 oxygen here. So let me simply make it 3 here. Now I have 3 atoms of oxygen on the reactant side. I have 3 atoms of oxygen on the product side. But now hydrogen, I have 3 times 2 is 6. I have 6 atoms of hydrogen on the reactant side, whereas only 2 atoms of hydrogen in the product side. So what is needed to be done? I have to just multiply this by 3. So now let's check. Twice of aluminium plus thrice of H2O gives me Al2O3 plus thrice of H2O. Everything is balanced. So P is 2, then H2O is 3, then Al2O3. I have one molecule of Al2O3, then 3. So 2313 is my order. 2313. So correct option is C. Are you able to follow, students? Please take one atom at a time. Check the number of atoms on the reactant side, on the product side, and try to balance it out. Okay. Again, students, now this question is from your acid, bases, and salts. There are the following table shows the pH value of 4 solutions A, B, C, and D. And I have put an arrow. So D has a pH value of 3. A has a pH value of 5. B has a pH value of 7 and C has a pH value of 13. Let's discuss, students. Now A, let's start from A. This A is having pH of 5, right? So what is 5 pH? I know that 7 is neutral. Below 7, we have acidic pH, but it's 5, so it's weakly acidic, right? Now B is 7, that means it's neutral. Now coming upon to C, I know above 7 it's basic, the pH is basic, but it's 13, that means it's highly basic, strong basic. And D, it's strongly acidic. So now the solutions A, B, C and D respectively are: A is weak acid, B is neutral, C is not a weak base, C is a strong base. So A option, strong acid, wrong. The B option, which is saying A is a weak acid, is true. B is neutral is true, but C weak base, no. So this is also not correct. Now let's move on to C option. A is weak acid, true. B is neutral, true. C is strong base, true. And D, is weak base? No, it's strong acid. So the correct option here would be D. A is weak acid, B is neutral, C is strong base, D is strong acid. So now students, this was quite simple one. They just gave you the pH values and you have to decide what is the what should be the solution, what is the nature of the solution. This was a direct one. Now let's move on to the next question. Again, this question is from metals and non-metals. The products when aluminium and magnesium are burnt in the presence of air. So we all know when aluminium and magnesium are burned in presence of air, what are the two compounds that are formed, students? Yes, it is Al2O3 and MgO. Okay, so now again, what you need to keep in mind here, students, that Al2O3 and MgO are being formed, right? Why? Because aluminium has an oxidation state of +3, right? Oxygen state of -2. When we interchange this, it will form Al2O3, right? Then again magnesium and oxygen. Magnesium has an oxidation state of 2 and oxygen has an oxidation state of -2. So when we combine this, it is going to be MgO, magnesium oxide and aluminum oxide. So the correct option is Al2O3 and MgO. Let's move on to the next one. You have three aqueous solutions A, B and C. One is of potassium nitrate, then aluminum chloride and sodium carbonate. The ascending order of pH of these solutions. Now student, it is saying ascending order. That means from the low pH to the highest pH. Now potassium nitrate, let's consider the first one. Okay, give me a moment, students. Yes, yes, learners, my dear learners. So now, potassium nitrate. Now, how is potassium nitrate formed? Potassium nitrate is formed from a strong base and strong acid. When potassium hydroxide, that is KOH, when combines with HNO3, gives me KNO3, right? So when strong acid and strong bases combining, that means this is a neutral salt. So neutral means pH of 7, right? Now ammonium chloride. How is ammonium chloride formed and how is sodium carbonate formed? Now, as I know, ammonium chloride is formed when, what happens when, what is the reaction? When ammonium, that is ammonium combines with HCl. So ammonium is combining with HCl, right students? So this is going to be the salt which is formed, which is ammonium chloride, is going to be slightly acidic in nature. Now sodium carbonate. We all know that sodium carbonate is basic in nature. That means its pH is going to be above 7. So if I arrange them in ascending order, then I have ammonium chloride with then potassium nitrate and then sodium carbonate. So BAC is my correct option. Are you able to follow, C student? Now again, this was a simple question, but then you have to remember the nature of these compounds, right? How are these compounds formed? So I can say that this is a part of acid bases, as well as you have to remember the chemical equation as well to solve this question. So here they combine two concepts together, right? Can I say this, that they combine two concepts together? Yes. Okay. Now, from metals and non-metals. The metals obtained from their molten chlorides by the process of electrolytic reduction. Now, what are the metals that are obtained from by the process of electrolytic reduction? Students, keep in mind for this, you must know one point, which is an important point. Let me first tell you the answer. The answer is calcium and magnesium. Now, why is my answer calcium and magnesium? Because students, please keep in mind that these metals come high up in the reactivity series. So these metals cannot be just simply reduced by carbon. Okay. So for such kind of metals which are high up in the reactivity series, what is the process to obtain these metals? They are obtained by electrolytic reduction. This is the main point which you have to keep in mind. Okay. Okay, students, this is a very basic question. The formation of magnesium oxide is correctly shown in which option? Now, students, I know that magnesium has a tendency to donate how many electrons? 2 electrons. And oxygen has a tendency to accept how many electrons, student? Again 2 electrons. So I know this thing. Now let's apply my knowledge. Up till now, the questions are simple. If you have brushed up your topics, then I hope you are able to answer these questions, right? Okay, give me a moment, students. Yes. So now let's consider all the options. In the first option, 2 electrons of magnesium are being given to oxygen. So magnesium acquires a valency of +2, oxygen acquires a valency of -2. This is correct. In the second case, 1 electron is being shared. This is wrong. In the third case, do I require 2 atoms? No. In the fourth case, 2 magnesium atoms? No. Which is the correct option? The first option. Yes? Okay. Now, the 11th question. This is from again chemical equations and reactions. So I have an assertion that decomposition reactions are generally endothermic reactions. And I know very well, students, that yes, decomposition reactions are endothermic reactions because you need to supply energy in order to have a breakdown of a molecule, right? Now, what is the reason which is being given? Decomposition of organic matter into compost is an exothermic process. Now, student, this is also correct that when an organic matter decomposes, then it's an exothermic process because energy is released. So, I know both my assertion and reason are correct. But now, tell me, is my reason correct explanation of assertion? No. The explanation for this assertion should be that energy is needed to be given since the extra energy is needed to be supplied in order to have the breakdown of a compound, right? This type of reason should be given, but here this reason does not justify my assertion. So I am going to go with B option, that both assertion and reason are correct, but reason is not the correct explanation of my assertion, right, students? So the option which is correct here is the B option. Yes? Okay, let's take on the B option. Now, student, this is a simple basic question. The body of human beings works in the pH range of 7.0 to 7.8. Right? Okay. So, let's take on this option, which is 7.0 and 7.8 to 7.8. Now, the next question. The warning sign shown in the given figure must invariably be displayed or pasted on the containers which contain hydroxide of. Now, students, I know that aluminum hydroxide is not so corrosive that it can, potentially cause a burn on my hands, right? A burn or maybe more than that. It's not that corrosive. Similarly, calcium hydroxide is also not that much corrosive, and magnesium is also not that much corrosive. Which one is corrosive? It's sodium hydroxide. I know you must have gone to your labs and you have heard your teachers saying, please handle sodium hydroxide carefully. Don't take it on palm directly, right? Because it is extremely corrosive. Now the next question. Aluminum powder is used in the thermite welding process. Remember, students, I told you that thermite process is one of the favorite questions of CBSE, right? So now let's read the options. It is the action with iron is highly exothermic. The first option is saying this thing. Then what is my second option saying? The second option saying that when it is heated with iron third oxide, molten iron is obtained. Okay, students, let's do one thing. Let's first write the reaction. What is going to be my reaction, and then let's compare the points and get to the final answer. Now, students, since we are solving this, are you observing the strategy which I adopt? What I do is I first understand the question, I process in my mind what is the question exactly saying. Then I try to figure out which is the correct right option. And for doing that, I eliminate the wrong ones. I follow this strategy, and this strategy always give me answer to eliminate the wrong ones. Then automatically you will have your right answer, right? So let's first, what we can do is first write the reaction. So I know that when iron oxide, that is Fe2O3, combines with aluminium, since aluminium is high in the reactivity series, it will displace iron from its oxide and will form Al2O3, and I will have iron, and also a large amount of energy is released. It's an exothermic process. So this is the reaction and I get this iron in my molten state. Okay. So its a reaction with its reaction with iron is highly exothermic. Okay. When it is heated with iron third oxide, we have taken iron third oxide, molten iron is obtained. Correct. This is also correct. When it is heated with iron third oxide, molten aluminium is obtained, which is used to join railway tracks. No, molten iron is obtained. This is not correct. Its melting point is low as compared to iron, and a molten alloy of iron and aluminium. No, no molten alloy is formed. So, which is the correct option? This one, B1. When it is heated with iron third oxide, molten iron is obtained. This is the correct option. And you know, student, the application of thermite welding process is that this molten iron, it goes to the railway tracks and it repairs the railway track. That is why the name is there, thermite welding. Welding of railway tracks, maintaining railway tracks, repairing them. Okay, so molten iron is obtained. Okay, let's move on to the next question. Two metals, zinc and tin, are dissolved separately in definite portions of molten copper, the primary metal. Right? Now, what is it asking? Two different alloys are obtained. So, remember, student, when copper combines with zinc, you have brass as an alloy. And when copper combines with tin, you have bronze as an alloy. This was pretty much direct question, right? Okay, so in which of the following situations a chemical reaction does not occur? When milk is left open at room temperature during summer, a chemical reaction occurs. Milks get curdle, right? So this is a chemical reaction. Grapes get fermented. Again, this is a chemical reaction. An iron nail is left exposed to humid atmosphere. We know that iron, when it is exposed to humid atmosphere, it undergoes corrosion. So this is also a chemical reaction. Corrosion is a chemical reaction. Melting of glaciers. Is it a chemical reaction, students? No, obviously not. This is not a chemical reaction. So what is my correct option? Melting of glaciers. Right, it's just a physical change. Melting of glaciers is a physical change. Remember that, not a chemical change. Okay, so in order to prepare dry hydrogen chloride gas in humid atmosphere, the gas produced is passed through a guard tube. Guard tube or basically drying tube, students, right? So now the drying tube, I know that I want a dry hydrogen chloride gas. Yes, I have to remove the moisture. So can I pass it through calcium oxide? No. It will give it moisture. Can I pass it through calcium hydroxide? No, it already has a hydroxide. Calcium carbonate, no, it is not going to give me the result. That is, it's not going to give me dry hydrogen gas. So what is the correct option? It's calcium chloride. Remember. Okay. The property by virtue of which solid material can be drawn into wires. So this is again a straight direct question. The properties of metals, malleability, ductility, sonorous, right? So what is it? Okay, again, sometimes I have seen that students commit mistake between malleability and ductility, right? So what is the correct option, students? When it's drawn into wires, it is ductility. Correct? Okay, so ductility is the correct option. Let's move on to the next one. Again, student, this question is from your chapter Carbon and its compound, and this question is pretty much easy. But you know what? When I read this question, I know one single bond, one triple bond. I can do it. But then here you have to keep one thing in mind. Let's check what is that one thing. First, it's benzene. Benzene does not have a triple bond, right? So I can simply eliminate this option. Okay, give me a moment. Yes, so I can simply eliminate this option benzene. Similarly, I can simply eliminate cyclohexane. Now I have two options, butane and propyne. Students, as you know, butane is Butane, the word root is but. But means how many carbons? 4 carbons, right? Ine, that means I have a triple bond. Let's take a triple bond here. So I have a triple bond here and I have a single bond here. So this is satisfying. Now let's consider propine. Propine again, ine, triple bond. I have a triple bond, I have a single bond. So these both are the options are correct. Now you might be thinking, ma'am, is the question wrong? No, dear students, the question is not wrong. Please read it once again. What is it saying? Only one carbon-carbon bond, one carbon-carbon triple bond. So one carbon-carbon bond is here, one carbon-carbon triple bond is here. So my correct option is propine, not butane. Please follow these things, because whenever you are doing exam, you're always in a hurry. So in a hurry, we tend to miss these points. Okay. Next question. The main observation while performing the experiment of burning magnesium ribbon in air. Now we all know what happens when magnesium ribbon is burnt in the presence of air. The magnesium ribbon burns with a dazzling white flame. Correct. The white powder is formed. Correct. Magnesium ribbon vaporizes. No, magnesium ribbon does not vaporizes. Aqueous solution of white powder turns blue litmus to red. As I know that magnesium ribbon, when it's burning in air, the magnesium oxide which is going to form is basic in nature. And what is the nature? So again, students, you need to have the knowledge of acid, bases and salts also here. What is the nature of base? Does it turn red litmus to blue or blue litmus to red? How I remember is acid means danger. Danger means red. So blue litmus to red, that means the compound is acidic. Base means, okay, fine. So pine means blue. So red to blue, basic, blue to red, acidic. Now I know that magnesium oxide which is going to be formed is a basic. So it will turn red litmus to blue, not blue litmus to red. So the two options which are correct are first and second. So the option which follows this thing is option number C. Okay, so let me take option number C. A metal displaces iron from its aqueous solution of ferrous sulfate, and what is it saying next? But fails to do so in the case of aluminum sulfate. Again, what you need to know, students, you have to have the knowledge of reactivity series. Let's write the reactivity series once again. What is it? Potassium, sodium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, then silver, then gold. Now I need up to this much, it's fine. So let's see what is it saying. A metal displaces iron from its aqueous solution. Iron from its ferrous sulfate. That means I have these many options, right? But now next look onto the next part of the question. Aluminum, but it fails to do so in the case of aluminum sulfate. It cannot replace aluminum from its salt. That means zinc is there. It can replace iron, but it cannot replace aluminum. So the correct option is zinc. It was pretty much direct. What I need to know is the reactivity series. That's it. Okay. A common feature observed in the crystals of washing soda, copper sulfate, gypsum, and ferrous sulfate is: does they all exhibit basic nature? No. Does they all are of acidic nature? No. Then they have fixed, what is the third option saying? The third option is saying that they have fixed number of molecules of water of crystallization in one formula unit of these salts. Yes, this is the correct option, right? Because I know washing soda. What is washing soda? It's sodium carbonate. So Na2CO3 dot 10H2O. Right. Then the next which is coming up is my gypsum. What is gypsum? Gypsum is CaSO4 dot 2H2O. What is next? Next is ferrous sulfate. So I know ferrous sulfate is FeSO4 dot 7H2O. And we are missing on one thing, which is washing soda. Copper sulfate, right. So what is copper sulfate? Copper sulfate is CuSO4 dot 5H2O. So they all have water molecules of crystallization, water molecules for crystallization. So C is the correct option. A metal X on on treatment with sodium hydroxide liberates a gas G. It also liberates the same gas G on treatment with dilute sulfuric acid based on the above information. X and G are respectively. So now students, what I know here, I know that metals when combined with acid liberates hydrogen gas. I know this thing, but it's saying a metal is combining with sodium hydroxide and liberating a gas G, right? So now student, this is an application based question which is testing your knowledge. So now a metal that can combine with acid as well as with a base are called amphoteric metal. We have two amphoteric metals, right? Which is the one which is there in our options? Zinc is there in our option. So zinc is the metal and the gas which is liberated is hydrogen. So what is my metal? The X. X is my zinc and the gas that is liberated is hydrogen. Again, it was a quite simple thing. What you need to keep in mind the concept of amphoteric metals, right? Okay, the next question. During electrolytic refining of copper, the anode and the cathode of the electrolyte used are respectively. Now students, tell me, when we are doing electrolytic refining of copper, what is kept at anode? At anode we have impure copper, right? And at cathode we have so at cathode we have pure copper. And what is used as an electrolyte? An electrolyte is acidified copper sulfate solution. This was a direct question. We have studied this electrolytic refining of copper. This is one of the most asked question of CBSE. An example of electrolytic refining, and we have studied in this in the chapter metals and non-metals. So first it's saying at anode. What is it? Anode, anode impure copper. At cathode pure copper, and solution is of acidified copper sulfate. So this is correct option, right? Okay, so a hydrocarbon which does not belong to the same homologous series of compounds. Now students, this is the question from carbon and its compound, and what you need to know here is that carbon and its compound in homologous series, they have a same general formula which is CnH2n plus 2. So whatever is following this formula is correct, but whichever compound is not following the formula is wrong. So let's check for the first one. Here N is 4, so C4, then twice of 4 is 8 plus 2 is 10. It is following. Then let's check for C6H14. Here N is 6, twice of 6 is 12 plus 2 is 14. It is also following. Then for C7, here N is 7, twice of 7, that is 7 times 2 is 14, plus 2 would be 16, but the option is saying 14, so this is wrong. C7H14 is wrong. Let's also check for the D1. C10 and H22. Here N is 10, 10 times 2 is 20, 20 plus 2 is 22, so it is also following. So the option which is not following this is C7H14. Again, this was a direct question, students. What you need to keep in mind, the homologous series, that they have a general formula which is CnH2n plus 2. Okay, now the next question is from juice, acid, bases and salts. Juice of tamarind turns blue litmus to red. It is because the presence of, we all know tamarind has tartaric acid, and tartaric acid, since it's an acid, and again I told you the trick to remember, acid means danger, so blue litmus to red. So tartaric acid. Now again there is a reaction where we have to balance out the chemical equation. Now students, as you can observe, we have at least solved two to three questions of just balancing the chemical equation. So now what can I conclude? That I need to be thorough with my balancing, right? So let's try to balance this out. Okay, give me a moment, students. Yes, so let's try to balance this out. I have A times of lead nitrate, which is heat. Again, students, tell me which type of reaction is this? It's a type of decomposition reaction. Please keep that in mind. Again, there is a slight revision of decomposition reaction as well. Lead oxide plus C plus D, O2. I have to give values of A, B, C and D. So let's try balancing this out. One molecule of lead, one molecule of lead. Fine. 3 times 2, 6 molecules of oxygen. In the product I have 1, 2 and 2. 5 molecules of oxygen. This is not balanced. One molecule of nitrogen, one molecule of nitrogen. So what is needed to get balance, student? Oxygen is needed to get balance. And how will you balance that? What can we do is, let's do this too. So lead nitrate, when we heat this, twice of lead oxide plus NO2 plus O2. Now can we check? Okay, so now if I check, I have two two lead molecules, two two oxygen molecules. Okay, two let's check, two oxygen, two and two. So here it's 6, 3 times 2 is 6, but here again, students, what is not balanced now? Lead is not balanced here. So what am I going to do now? Excuse me, dear students. Yes, students. So what is needed to be done here? Yes, students. Yes, students, excuse me just for a moment. Students, excuse me just for a moment. Okay, dear students, I'm sorry for the delay. Okay, let's go once again. So what I did, I tried balancing the oxygen, but then if I take two molecules of lead here, then in the reactant side there is only one molecule of lead, right? So I have to change this one. So now what can I do? Okay, let's check what needs to be done. So student, if I do 2 here, I can write 2 here. So now my lead is balanced, but then again I have a problem. Now the number of nitrogen and oxygen atoms are not balanced. To keep this, what is needed to be done, let's write this one as 4. Okay, now let's check. So I have two atoms of lead, right? Two atoms of lead. Then how many atoms of nitrate, students? And check for here as well. So two atoms of nitrogen, students, and 2 and 2, 4 atoms of nitrogen, right? Then 3 times 2 is 6, and then 2 more. So 4. 4 times 2 is 8. 8 plus 2 is 10. 10 plus 2 is 12. And here 3 times 2 is 6. 6 into 2 is 12. Now everything is balanced. Let me summarize this up once again, students. What I did is I have to balance this equation. First, I thought let's do this. Let's put a 2 here. So when I put a 2 here, I noticed my oxygen got balanced, but then my lead was not balanced. So in order to balance this out, I put a 2 here. So when I put a 2 here, I got two atoms of lead on the reactant side as well as the product side. This is balanced. Good. But 3 times 2 is 6. 6 times 2 is 12. I have 12 oxygen atoms now. In order to make it 12, I knew that we have 2 and 2 here. That means 4. I need how many atoms more? 8 atoms more. That is why I put 4 here, and by doing that my nitrogen also got balanced. So I have 2, 2, 4, 1 as my correct option, which is D. Okay, students, now are you able to follow it? Yes. Okay, so the next question is from carbon and its compound, which is saying choose the incorrect statement choose the incorrect statement about the common reaction used in hydrogenation of vegetable oils. So now I know vegetable oils, when hydrogenation of vegetable oil is what kind of reaction, students? It is an addition reaction, right? So this is a correct option. This is an addition reaction. It takes place in the presence of nickel and palladium catalyst. Correct. It takes place in the presence of nickel and palladium catalyst. The product contain only single bonds. Yes, because in addition reaction, what we do? We convert the compound having double bonds, because I know vegetable oils are compounds having double bonds. So I convert the compound having double bond to a compound having single bond, right? So what I do, we have, it's an addition reaction, and addition of hydrogen takes place in vegetable oils in the presence of nickel and palladium as the catalyst, right? So if we take this reaction, okay, if we take this reaction, addition of hydrogen will break this bond and this will become this, right? Yes. So the product contain only single bond between carbon-carbon atoms. True. It is an addition reaction which occurs in the presence of an acid catalyst. False. It occurs in the presence of nickel and palladium. Now coming upon to the assertion and reason. The metal high up in reactivity series cannot be obtained from their compounds by heating with carbon. Absolutely correct. Then what is the next question? Displacement reaction can also be used to obtain metal. This is also correct, student. The assertion is correct. The reason is also correct. But as you can see, this is not the correct explanation of the reason is not the correct explanation of the assertion. So B option. Again, assertion and reason. Concentrated nitric acid is diluted by adding water slowly to acid with constant stirring. Students, here only we have the answer: concentrated nitric acid. Concentrated nitric acid, when we have to dilute an acid, students, what is done? Water is added to acid or acid is added to water? Tell me. If you have a concentrated acid and you will directly add water, what will happen? The acid will splash out, right? You must have learned this while performing your lab experiments, right? So this is a basic thing we need to keep in mind. So assertion is wrong. What is the reason? Saying concentrated nitric acid is easily soluble in water, and I know it's easily soluble in water, right? So assertion is false, but reason is true. This is going to be my option. Carbon and its compound are major sources of fuels, correct? Most carbon compounds on burning release a large amount of heat and light. We know carbon and its compounds, so the fuels like petroleum have, when they are burnt, they release large amount of energy, right? So assertion is also true, reason is also true, and here the reason is correct explanation for our assertion. Students, what is the key to solve assertion and reason type questions? Please keep that in mind, that first read the assertion properly, analyze what the assertion is saying, and then read the reason. Analyze the reason first. Analyze whether the assertion is true. Okay, if it's true, move on to the reason. Analyze the reason whether it's true or false. Analyze that. Then analyze the why part. Is the why answer coming correct? If it's correct, then go with the first option. If the reason and assertion are correct, but they are not justifying themselves, go with the second option, right? Okay. Assertion, sorry. Silver chloride turns gray in sunlight, right? Silver chloride turns gray in sunlight because silver chloride is a white colored compound, students. Please note that silver chloride is a white colored compound. So when this compound is kept under sunlight, it undergoes decomposition, right? So reason, decomposition of silver chloride into silver and chlorine takes place by the sunlight. That is also correct. Decomposition occurs in the place of, in the presence of sunlight. So both assertion and reason is correct, and assertion is the correct explanation of reason. So students, we practice quite a lot of questions today, right? Now, as you able to figure out, there are questions, there are topics which are repetitively being asked. For example, the reactivity series of the metal is being repetitively asked, right? Then the question for balancing out the chemical reaction repetitively being asked, right? Then there are questions from your pH. Then we have questions of the reaction of metal oxides, right? Then again, thermite process is also asked. Amphoteric metals are also asked, right? So these are some of the questions which are being repeated. So please keep these topic in mind, practice these topics, and then in the next session we will be back with another sets of question and to enhance your learning and your practicing so that you can become a topper. That's all, student, for today. Thank you for joining. Keep learning, keep smiling.